Let's move on to the next chapter called as friction. So here in the chapter, we try to understand how the friction is important in our daily life. And the second point we understand is how this friction is going to help in the daily life application. And the third one is we talk about classification of the friction. So upon completion, you'll be able to understand the importance of friction, how the friction is important, why it is needed in any of the system, or if any of the action is being performed, why there is a need of friction. And the second case is that the desirability of friction, or why friction is desirable, or how it is going to help us in completing the required work. And the third, we talk about classification of friction. Next, let's try to understand the role of friction with a simple case if the vehicle is moving on a road. So if the vehicle is moving on a road, under what circumstances the motion of the vehicle will be controlled, and how far we are able to control the motion of the vehicle effectively, and what needs to be done so that the controlling becomes easier. All these things will be trying to understand with a simple example of vehicle. So second factor is that here, if the vehicle is moving on the road, what is that external factor that is going to influence the motion of the vehicle? And third one, we try to understand the smoothness of vehicle when it is moved over a glass, or if it is running on a rough road. And the last part we have is whether the friction existing for a moving vehicle, is it desirable or not, or for any of the machine component, is it desirable or not. That is what we try to understand. Next is, what is the meaning of friction? So when the two surfaces are in contact, there is no resistance to movement. Smooth surfaces. When they say it is smooth surfaces, so the profile of the surface will be almost flat, and the profile of another surface will be almost flat. So these two surfaces tend to slide over each other. This is, let's say, surface 1 and surface 2. It tends to slide over each other or slip over each other. Slip over each other. Now let's talk about the rough surfaces. When the two real surfaces are in contact, then the resistance between the part is due to the surface irregularities. So instead of the surface 1 will be definitely having some irregularities. So that irregularities will be some appearing like this. Let's call it as surface 1. Same way, surface 2 will also definitely have some irregularities. Okay, so when they are brought in contact, these two irregularities engage. These irregularities, they are going to engage, and they will be offering resistance. So once they are brought in contact, let's say this is the assembly. So after assembling this is the irregularity of the surface number 1 and irregularity of the surface number 2. It could be something like this. So it would be intersection of peak and valleys. That's how it would be. Almost intersection or almost meeting of peak and valleys it would be. So here, as and when you try to pull the surface number 1 over 2, Definitely, here you can see the interaction of these 2 points, due to which these two contact points will be offering the resistance in the opposite direction. Will be offering resistance in the opposite direction. So this resistance, what we call it as friction, and that's how the friction will be present. Until and unless if the surface is smooth, or if we are able to reduce the heights of these peak and valleys, then to a greater extent the surface would be approximately smooth, and the friction might be present but it will be very, very less. Now let's try to understand the same thing with another diagram. So here you can see the interaction with the contact points, and then if any one of the surfaces, let's say the top surface, is being pulled by a force P, then at this point the resistances are going to develop. So R4, R3, R2 and R1, all these are going to indicate the resistances. These are the point which will offer the resistances against the load P, against load P or effort P. Now let's try to understand the significance of friction. So friction is undesirable. This behavior friction is undesirable in the bearings or in the moving parts, because if the friction is present, then the bearing has a tendency to get jammed, and when the machine, if any one of the machine or the rotating part gets jammed or locked, then the severity of loading is going to get increased, and that's when is going to result the failure of machine component. That's when we see the armature of the motor also gets burned out. So here we need to identify this scenario, and then we need to provide appropriate lubrication so that this jamming can be avoided. So here the friction behavior is not at all supportive. It is not going to support the system for working. And secondly, it is going to reduce the efficiency of the machines. And when the friction is desirable, likewise you might have seen in the ships, okay, so the traditional ships, so they would be having some cloth like this, and then there would be an arrangement of let's say wooden bars, and on that the cloth is being tied. So this is to indicate this cloth is taken as an help to move the ship forward by utilizing the wind energy. So this cloth is clamped to the wooden rods by means of some rope, and this is going to be very heavy in weight, and to control this weight you will be using some devices or some rods, and then to that the rope is being tied. So rope surface has got already the roughness, and that roughness is going to give the resistance, and that resistance will be controlling the motion of this large structure. So that is how the importance of the friction can be realized. And let's take an example, like if we are trying to walk, the shoe sole is going to consist of some irregularities. With those irregularities we will be able to provide some grip on the road on which we are walking. So that is the case when the friction is desirable. And apart from these applications, it is desirable in clamping and friction devices. So if I want to hold a workpiece, inside a 3-jaw chuck or a bench vise, let's take an example of bench vise itself. So you will be studying this in the first year of workshop. So bench vise clamp is going to consist of rectangular plates, and on that rectangular plates we'll find some impressions like this. These impressions are nothing but it will give you the indication of roughness, and this roughness is going to prevent the motion of workpiece. The workpiece, let's say when it is clamped between two jaws, so and you are trying to perform some cutting operation, so you don't want this workpiece to be moved. This workpiece should not be moved, and this is a very basic kind of an application which we come across in our daily life. So that is when the importance of friction or existence of friction is highly needed. Next would be the friction also plays major role in the braking systems. So if the vehicle is if you are unable to retard any vehicle, it means the rubber lining or the friction lining would be definitely there. Okay, so that lining, if it is worn out, then definitely you cannot reduce the motion or the kinetic energy of the system, and that's how the braking fails. So friction is highly very important. Yes, it is going to reduce the efficiency, but and it is also going to help us in controlling, I should say. More or less, this is the desirable. Friction helps in controlling motion. Now let's see the classification of the friction. So here we have got the types of friction. So one is the dry or solid friction. The solid friction involves two surfaces which are of solid type, and another one is fluid friction. So between the surfaces we have got a fluid or some lubricant or some oil that has been present. So likewise you might have come across the example. Let me go back to the old slide wherein you are performing the cutting operation on the workpiece. So sometimes for cutting the workpiece, we would be using water or oil as a lubricant so that the cutting becomes easier. Even this kind of approach is being also done in the pipe cutting or pipe threading, I should say, to be precise. Pipe threading, especially when we perform that, then we are going to use the cutting fluid. So this is where the fluid or fluid friction is going to come into existence. As well as about fluid friction, we will be talking separately on a subject called as fluid mechanics. So there you might get into more details. And now coming to the next type of classification. So here the classification of friction is based on the state, that is either rest or type of motion. So if it is in rest, then it is static friction, and if the body is in motion, then the static friction is replaced with the dynamic friction. So this is based on the motion of body, based on state of body, I should say, state of body. Now next we have the dynamic friction is being divided into two categories, that is based on the sliding friction and rolling friction. So in the sliding friction, the tendency is that one surface tends to move or tends to slide over another surface, more or less like a translatory kind of motion, more or less like translatory motion. And in rolling motion, here you can see area contact would be definitely there between the surfaces. And in case of rolling friction, the on the surface we will be placing a cylindrical or spherical body which is going to move over it, and the resistance here, it will be very less. Cylinder or sphere would be moved over some surface, and since it is going to form a line or point contact, and here multiple resistances are being formed at each point. Multiple resistances are being formed. So here in the sliding friction, the resistance is more, and whereas in rolling friction, the resistance is very less. So when these two kind of frictions are desirable, we will try to understand as we progress into this chapter furthermore. Let's talk about dry friction. Dry friction in the sense there is the lubricant that is absent between the surfaces. The friction exists between the perfectly clean and dry solid surfaces, and no interference of fluid between the surfaces is observed, especially in dry friction. So as far as our subject is concerned, we talk about only dry friction. The fluid friction will be taken in a different subject. So here no direct contact between the surfaces, and the lubricant is present between the contacting surfaces. So let's say this is a surface number 1 and surface number 2. Between these two surfaces, a lubricant or grease or some oil would be definitely present. This would be fluid. So here the fluid between the two surfaces, the friction between the two surfaces is separated by a film of lubricant. And let me just write this properly. This is surface 2. So here, as you can see, that fluid film is there, and the thickness of the fluid film is going to be definitely very, very less, and this is also called as fluid friction or viscous friction as well. Now let's try to understand the other part or the other keyword that is called as static friction. So as I mentioned earlier, the static friction involves only for those bodies which are in rest, and the force is going to be not capable to move the body. So here if the body is at rest and it is on the resting on the horizontal surface, and the force is being imposed, the force P is applied in a way, then this P will not move the body. The motion of P is, or the motion of the body is impending. Here I can say the body at rest or motion of body is impending. So here it involves with body at rest. This is the keyword you need to remember. Next is the dynamic friction. So dynamic friction is friction force acting on a body which is actually in motion. So now the P has the ability to move the body which is in motion. So here what happens is that the resistances on the block and the resistances on the ground, they will coincide or they will assemble with each other, and the resistance will be offered against P. This is going to be the friction force. So as mentioned earlier, that is dynamic friction could be of sliding friction, or even it could be of rolling friction type. So sliding friction involves the surfaces trying to move over each other. More or less, as I mentioned, it is the kind of motion between the surfaces would be translation, and they would be having area contact type. Area contact, it will try to establish the contact at the multiple number of points, or the surface to surface contact is also observed. Whereas in rolling friction, line or point contact will be there, and due to which the motion is going to be rolling. We'll understand this rolling motion at the later stage. And here the resistance is less. And here in the sliding friction, resistance is more. So when the resistance is more, the rate of wear and tear is definitely more. Rate of wear and tear of surfaces is more. Here the rate of wear and tear is less. So that's all about the friction we have in the introduction part.